So what does it mean to have a normal distribution? And usually what we're talking about is the entire population having a normal distribution. Well, if our population is normally distributed, then if we took everybody in the population or everything in the population and plotted its values, we would get a nice graph that looks like this. This is what we call a normal curve. It represents the normal distribution. So what is it? What are we looking at? We describe this as a bell-shaped curve. It's symmetric and it has thin tails. Its tails trail off to the right and left, kind of fastish. So this is a normal distribution curve. And as I said, we think of it as applying to the population. In particular, we think of the area under this curve as corresponding to the percent of the population for which our variable has a certain range of values. And there are some specific values that we should know. Looking at this picture, you'll notice that our horizontal axis has some labels. These labels are based on the mean and the standard deviation. Of our actual population, which we'll say is close enough to being the same as the mean and standard deviation of our sample. So when we say that the data are normally distributed, we mean that the portions of the population that are a certain distance from the mean correspond to that specific shape. There are some specific numbers we can attach to this. These numbers are approximate, but they're rounded to make them easy to remember. If a certain variable is normally distributed in the population, then about 68% of the population has a value within 1 standard deviation of the mean, 95% of the population has a value within 2, and 99.7% of the population has a value within 3 standard deviations of the mean. Now keep in mind these numbers are all rounded in order to give us just nice numbers to remember, but they're close. Let's see an example of how we actually parse that. In a certain year, maybe the mean SAT composite score was a 1050 and the standard deviation was 160. To be within 1 standard deviation of the mean means to be between the mean minus the standard deviation which is 890, and the mean plus the standard deviation, which is 1210. So this means that 68% of the students who took the SAT that year had a score between 890 and 1210. To be within 2 standard deviations of the mean means to be between 1050 minus 2 times the standard deviation, which is 730, and 150 plus 2 times the standard deviation. Sorry, not 150. The mean is 1050. So 1050 plus 2 times 160 is 1370. So this means that 95% of the students who took the SAT that year had a score between 730 and 1370. To be within 3 standard deviations of the mean means to be between 1050 minus 3 times 160, which is 570, and 1050 plus 3 times 160, which is 1530. So according to the empirical rule, if that's the mean and the standard deviation, 99.7% of students who took the SAT that year had a score between 570 and 1530. In the next video, we'll see how to apply the empirical rule to actually answer questions whose answers we might be interested in.